Okay, so this will be a screencast for the factors affecting the concentration of the hydrogen ions. So recall, what is an acid? An acid is a substance that produces hydrogen ions when they are dissolved or ionized in water. So what makes an acid acidic? Which part of the acid is that? It is the hydrogen ions. So because of this, how fast an acid reacts with something else is actually dependent on what is the concentration of hydrogen ions that are in the solution. So today we'll look at the three factors that affect concentration of hydrogen ions, which are strength, concentration, and basicity of an acid. Well, this affects the concentration of the hydrogen ion. Okay, so the strength of an acid is dependent on the extent of dissociation into hydrogen ions. There are two signs here for an arrow. The one that we usually draw is this, which represents a complete dissociation. There's something new here, which is this symbol. Okay, how do we draw this? You draw from left to right, a straight line across, then you hook up. Then from right to left, draw across, then you hook down. That's how we draw the reversible arrow. How do we use it? A strong acid would have dissociate completely in water. Because it dissociates completely in water, we use the full arrow, which is, for example, HCl. When I dissolve it in water, I get H plus and Cl minus completely. For a weak acid, it will dissociate partially in water. For example, your ethanoic acid will dissociate partially, and I'll use this reversible arrow. Okay, so a strong acid and a weak acid, how do they differ in terms of the drawing? Okay, so if we look at the left hand side over here, let me change the color. Okay, let's say before I add it into water, I have 3 acid molecules. Okay, after I add it into water, note that all of them completely dissociated. Whereas a weak acid, let's say I also have 3 acid molecules. Okay, ignore the A, right? It just represent any N ion that it can be. Okay, so it can be nitrate ions, it can be chloride ions because it's a A minus. So on the right hand side, I have HA, 3 molecules again. But if it's a weak acid, only, let's say, one of them out of all 3 will dissociate. So not all 3 acid molecules will dissociate. Therefore, it's not 100% dissociated. It is not a strong acid. So what are some examples of strong and weak acid? Strong acids are commonly the inorganic acids such as your HCl, HNO3, and H2SO4. What is a weak acid? They are usually your organic acid such as your CH3, COOH. So, next, what is a strong or weak alkali? Okay, strong or weak alkali is dependent on their extent of dissociation to give hydroxide ions. Again, complete dissociation is a full arrow, partial is a reversible arrow. So a strong alkali dissociates completely in water. For example, your NaOH, which will dissociate into Na plus and OH minus. A weak alkali is, for example, your aqueous ammonia, who dissociates partially in water. Okay, so you may be wondering, why is it that ammonia is an alkali? That's because ammonia can react with water to give ammonium ions and hydroxide ions. So long as you give hydroxide ions in solution, you are an alkali. Oh, I realized that I forgot to fill in the blanks for the part before the alkali. So the greater the strength of an acid, the greater the degree of ionization to hydrogen ions, thus the higher the concentration of hydrogen ions. So I repeat, the greater the strength of an acid, the greater the degree of ionization to hydrogen ions, thus the higher the concentration of hydrogen ions. Next, if you look at a strong and weak alkali, actually it's the same kind of diagram. It's just that instead of a anion A that I represent just now, I use a cation B. So let's say there's 3 molecules again. After I put it into water, all 3 will dissociate. Okay, note that this is also supposed to be dissociated. It should be further away. So when you draw it, can you just draw it further away? So all 3 will dissociate to give hydroxide ions. Whereas a weak alkali, let's say out of 3, only 1 dissociates. Okay, so because hydroxide is OH minus, that's why the corresponding charge on B is B plus. Okay, next we have what is concentration. Now when I talk to you about, like, let's say, what do I mean when I say, oh, today the Milo that I drink is very concentrated? Okay, it means that the Milo that I drink has a lot of Milo powder with, let's say, very little water. Okay, so it's about the amount of Milo powder per cm cube. Do you agree? Okay, so what is concentration in chemistry? It is the number of moles of acid molecules per unit volume. Okay, maybe you just want to copy that down first. Okay, what is number of moles? Moles is a counting unit. For instance, let's say I went to buy a dozen of eggs. By a dozen, you know that I mean 12 eggs was bought. So if I say that there was 1 mole of acid molecules, how much do I mean? Okay, I mean 1 mole is equals to 6 times 10 to the power of 23 number of molecules. This is a huge number, okay, because a lot of molecules or ions can be packed in a very small space. They are all very small. That's why we need some counting unit that encompass a large number, so it's more convenient for us to count. You will learn more about this when you are in Sec 3. Okay, so what is example of a concentrated solution is, let's say, a 5 mole per dn cube HCl solution, whereas a 0.01 mole per dn cube solution is considered as diluted. Okay, so the higher the concentration of an acid, the greater the concentration of hydrogen ions. Okay, the greater the concentration of an acid, the higher the concentration of an acid, the higher the concentration of hydrogen ions. Conversely, the higher the concentration of an alkali, the higher the concentration of hydroxide ions. Okay, so here's a joke. Don't drink water when you're studying. Why? Because chemistry says that concentration will decrease when we add water. Yeah. Take a while to let it sink in. Okay, do you understand this joke? Haha, okay. Next, basicity. Now this is at the last page of your acids notes. So maybe you want to take it out first. Okay, so when I talk about basicity, you may think about number of moles of base or something. But actually, it is in reference to the maximum number of hydrogen ions that's produced per molecule of acid when I fully dissociate it. What do I mean by this statement? Okay, something that is monobasic would only give me 1 hydrogen ion per acid molecule. If it's a dibasic acid, for 1 acid molecule, it will give me 2 hydrogen ions. For a tribasic acid, 1 acid molecule will give me 3 hydrogen ions. So what are some examples of monobasic, dibasic, and tribasic acids? First, a monobasic acid is like your HCl and HNO3. Notice that for one HCl molecule, I will only have one H plus ion being formed. A dibasic acid would be like your H2SO4 or carbonic acid H2CO3. Now this is something new that I haven't talked to you about. Do you drink carbonated drink? Gassy drinks? Okay, so how do we make gassy drinks? We actually, under compressed pressure, we are pumping in the carbon dioxide into the solution. So when we are doing so, CO2 plus H2O, what happens is it actually reacts and give H2CO3. Okay, this is because your carbon dioxide is actually what we call an acidic oxide. Okay, we will talk more about the natures of oxides next lesson, I think. Okay, so after carbonic acid, because of it reacts with water to give carbonic acid, that's why the time when we test for Sprite, it was slightly acidic. Okay, because I use this reversible symbol, what do you think is the strength of this acid? Because I use the reversible symbol, this acid is a weak acid. Okay. Lastly, we have tribasic acid such as H3PO4, where for one molecule of H3PO4, I'll have 3 H plus ions. Okay, next. Here's the structure of ethanoic acid. CH3COOH. Okay. Based on this drawing, do you think it's a monobasic, dibasic, tribasic, or polybasic? Okay, the answer is actually it is only monobasic. Why? Because we need to look out for the COOH group. Okay, COOH group is the acid group of a organic acid, and within the COOH group, only the hydrogen that's attached in the COOH group will dissociate. So in exam, if I give you a structure of an organic compound, you must be able to tell me that how many hydrogen ions are dissociated. So for that, you need to look out for the number of COOH groups. For instance, let's say I have this organic compound. For this compound, what is the basicity of this compound? Okay, the answer is actually dibasic because only these two hydrogen will be produced. If you look at it, there's two acid group, so therefore it's a dibasic acid. Okay, strength. How do we differentiate a strong acid from a weak acid with a chemical test? Okay, you can add a magnesium ribbon to a petri dish of hydrochloric acid and ethanoic acid respectively. Then we can observe the resulting effervescence and see which is more vigorous. Okay, let's show you the video now. Let me see. This is my class doing titration in Sec 4. Okay, you will also be able to do it next time. Let's watch this video. Okay, so currently on the left hand side, on your left, but on my right in the video, I'm adding HCl. Okay, pouring out HCl to cover the petri dish. The other side, I'm going to add ethanoic acid. So based on what I've already taught you, which is the strong acid and which is the weak acid. Okay, covering the base. So now I'm going to add 1 or 2 drops of food coloring to so that you can see the colors better. Shake a bit, okay, shake a bit. Now what I'm going to do is I'm going to add magnesium ribbon to each of them. Remember that the one on your left is HCl, the one on your right is ethanoic acid. Okay, so what I want you to observe is how vigorous the effervescence is on each side. Go. Okay, it's very obvious from the start that the HCl side has way more vigorous effervescence than the ethanoic acid side. But ethanoic acid, just note that there's also effervescence. Just to recall, what gas is being produced in this reaction and how do I test for it? Okay, hydrogen gas is actually produced in this reaction, and to test for it, you use a lighted splint. Okay, so you can see just by observing that HCl will give a more vigorous effervescence. This to assume that they are at the same concentration so that the comparison is fair. Okay. So, at the same concentration, a strong acid will dissociate completely to give a higher concentration of hydrogen ions than a weak acid. Now, does this make sense to you? Okay, at the same concentration, a strong acid dissociates completely to give a higher concentration of hydrogen ions. Hence, a strong acid would react faster than a weak acid with a metal, or if you use a metal carbonate. How do we quantify how fast it is? We can measure the time taken for a fixed volume of gas to be evolved from the two reactions to tell the strength of the acid. So for instance, you can have one test tube. For instance, you can have one test tube, okay, with the acid here. Then you have your metal here. You can bubble the gas evolve into a syringe. Okay, so just by how much the syringe moves in a time period, you can tell how much gas is being evolved. Okay, 3 factors that affect the way an acid behaves. Can you think about it? Do you think that the concentration of an acid will affect the strength of an acid? And can a weak acid have the same pH as a strong acid? Think about these two statements. Write down your stand first before I reveal the answer. Okay, do you think the concentration of an acid affects the strength of an acid? Now, a lot of students always think so, but this is actually a common misconception. A weak acid always dissociates partially, and a strong acid always dissociates fully regardless of the concentration. Okay, if you don't understand, I will explain with an analogy, so just copy down this statement. Next, can a weak acid have the same pH as a strong acid? Now, students also always think that a weak acid always have a fixed pH and a strong acid always have a fixed pH of, like, let's say 1. But because concentration also affects the concentration of hydrogen ions, which is what pH is measuring, so a very concentrated weak acid can have the same number of moles of hydrogen ions as a very diluted strong acid, giving them the same pH. Okay, so what do I mean? Let's give you an analogy. Let's say there's me as a soccer player. So my strength is very weak. I'm only able to score 1 goal per game. Okay, that's my strength. Here's Cristiano Ronaldo. He's a strong player. He can score 10 goals per game. So, what if I multiply myself? I copy myself 10 times, so there's 10 of me versus 1 Cristiano Ronaldo. Okay, note that if there's 10 of me and each of me score 1 goal per game, I will rival Cristiano Ronaldo in a soccer match. Okay, so in a sense, it's like I'm the weak acid and he's the strong acid. Okay, when my concentration increases, I'm able to get the same number of moles of hydrogen ions as compared to Cristiano Ronaldo, the strong acid. But even when my concentration increased, did my strength as a player change? No, it did not. Individually, I'm still weak. So, the strength of the acid is an independent factor. It is not affected by anything else. It is only determined by the nature of the acid. Okay? Nothing can change the strength of an acid, though increasing the concentration will also affect the concentration of hydrogen ions formed. Okay, so that's my analogy. You can think of your analogy also. So this is all for the strength of an acid.